Hello and welcome to Mitsubishi Electric Webinars. My name is John Harity and I work within the marketing group here at MEAU. The following Application Solutions webinar will cover continuous motion wrapping applications in the packaging industry, where we will take a look at how Mitsubishi Electric's factory automation products can be used to create a very powerful solution. I'd like to thank you for attending this webinar, and I hope that you can use this material in future wrapping applications. First, let's discuss a little bit about the different types of wrapping machines in the field. Essentially, many of the wrapping applications in the packaging industry involve simple horizontal and vertical indexing movements to bring a sheet of plastic, for example, around a product and then to cut and seal it into a circular shape before it gets shrink-wrapped or vacuum sealed. Have you ever wondered, for example, how the plastic that covers bulk packages of bottled water gets placed around the bottles? Or how about that annoying plastic that covers all the new CDs you buy? If you look around the grocery store, especially in the meat and produce sections, you'll notice several products that have been wrapped in plastic. The application in this webinar has been based around a continuous wrapping machine built for tray overwrapping. Let's take a look at the application here. Packages are indexed one by one with an indexing servo motor, slave axis number 2. So that each product can be evenly spaced on the main conveyor. A variable frequency drive controls an induction motor to transfer each package into the flying shear cutting station before entering the heat chamber. Here you'll notice the master encoder, which is used to track the relative speed of the product conveyor so that the flying knife or flying shear cutting axis can match the speed of the products for its cutting motion. Continuous wrapping machines can be used in a variety of applications, such as those for bottle and case wrapping, box wrapping, shrink wrapping, and tray overwrapping, such as the example shown here. Using Mitsubishi Electric products, the core component in this wrapping application is the MR-J3 series servo amplifiers. As shown below on the bottom right, 2 servo amplifiers are connected to a standalone motion controller, the Q170M CPU. Depending on the type of machine and its setup, the servos are capable of running the machine so that it can produce anywhere from 50 to 100 pieces per minute. The flying shear servo axis is commanded to move based on command pulses from the master encoder. The master encoder is connected to the product conveyor, which is controlled by an FR-E700 inverter via a CC-Link network. A special networking card, the FR-A7NC, is used here to communicate with the CC-Link master module in the Q55B extension base. Other modules include a temperature controller for the heat chamber, a dual input-output module, and a data logger module. A Mitsubishi GOT, or HMI terminal, is also connected to the system for operator control and diagnostic monitoring and troubleshooting. Applying Mitsubishi products in this application reduces the total cost of ownership for the customer through combining a diverse range of very strong products. All of Mitsubishi's application solutions provide specific advantages and benefits in terms of increased performance, product lifetime and quality, and reduced setup time. For the wrapping solution here, 3 particular features stand out that make the solution particularly valuable. The first highlight is the method used to continuously wrap each product. Continuous wrapping not only increases the machine's throughput, but it also reduces the chance for viscous fluids to spill or leak out of the trays while they pass through the machine. The second highlight included is the ability to intelligently index trays onto the main conveyor belt with an address mode clutch so that each product can enter the flying shear station safely. An intelligent indexing axis reduces waste material and assists in providing safe machine operation. With products accurately placed on the main conveyor, the machine's throughput can also be improved. The third feature of this solution to bring added value to a customer is the flexibility of using a data logger module to track lot code and date information. This is especially important for food wrapping applications. The data logger module also helps with predictive maintenance and can generate automatic reports. When breaking down this application to understand how the indexing and flying shear servo axes are being controlled, the best place to start is the layout of the mechanical editor. Here you'll see that everything is being controlled by the master encoder, which is configured as the drive module. The master encoder feeds pulses into the system through an electronic drive shaft to control both servo axes. Each of the spindle gears on the main shaft are configured for one-to-one follow with the master encoder, so that the speed of the servos can automatically match the speed of the conveyor. Pulses from the encoder provide independent control to both of the slave servo axes based on the operation of the smoothing clutches. The flying shear servo axis is shown on the left, while the indexer axis is displayed on the right. A virtual auxiliary servo motor is used to return the flying shear axis to its start position after completing a follow move for a specified distance. During the follow move, a pneumatic valve is used to provide the cut for the plastic material. A smoothing clutch for the indexing axis is used here to prevent products from slipping on the loading conveyor so that a constant gap distance can be maintained. This is critical to avoid jerky movements while loading products onto the main conveyor. In this program, you'll also notice direct clutches being used for both of the virtual auxiliary servo motors. For the flying shear axis, this clutch is always on to allow the servo to return to its home position after every seal and cut process. For the indexer axis, since there is no need to add or subtract speed for indexing, this clutch is never actually used. It's been provided, however, to offer additional flexibility for other machines. Now, let's take a closer look at how to perform a flying shear or a flying saw operation with a Mitsubishi electric motion controller system. This method can also be applied to a variety of other applications, and it is useful for anyone who needs to configure an address mode clutch. Take a look at the master encoder axis. The conveyor belt, which is coupled with the encoder, is continuously moving, which is shown with the red arrow. The servo axis is not moving since the clutch is open. As soon as a tray product approaches the flying shear station, the product sensor turns on, which indicates that the product is X amount of encoder pulses or counts away from the servo axis. This amount, X, is set to become the clutch on address, indicating the location where the clutch must engage so that the servo can begin following the encoder. Once this on address is reached, the clutch closes automatically, and the servo begins moving. Here you can see the red arrows that indicate forward movement on the differential gear and the servo axis. The servo accelerates to match the speed of the encoder and will stop moving after it reaches the clutch's off address, as defined by the user. You'll also notice that the pneumatic cutter axis is triggered independently during this follow movement. Finally, once the servo has decelerated to a stop after the cut has taken place, the clutch opens and the virtual auxiliary servo motor on the bottom left is commanded to reverse the motor to its home position. You'll notice the dotted arrow on the servo output module at the bottom, which indicates rotation in the reverse direction. In the timing chart, you'll also notice that the return movement takes place at a faster speed in order to improve the machine's throughput. This process is then repeated continuously as products arrive at the product sensor. The last technical